Okie doke. Let's talk a little bit more about some more of these angle and triangle properties. So on this one, we want to find G. So what's cool about this is that the first thing I notice is parallel lines. So I'm going to try to do this. I notice parallel lines. And I want you to realize that when I write stuff out like this, I'm not giving you a list of steps that you must follow. It's more of a things that I noticed, kind of what I did. So in this case right here, I'm numbering them. You don't normally have to. So maybe I kind of give one of these, you know, like just a flow of consciousness. I noticed parallel lines and a transversal. The reason I like this is because it makes my job easier. I don't have to draw an auxiliary line. I don't have to invent anything. I can, though. So in this case right here, I could totally find an auxiliary line. I could make one. I could just do it like this and say it's parallel. But let's see if we can do it without that. We don't necessarily have to do that. So one thing I could do, right? I could say that this is a vertical angle with G. Okay? I could say that that's a vertical angle with G. And then I could use some of my properties of transversals to kind of help guide me a little bit. But let's go to that. So I'm going to go ahead and highlight my the transversals I care about right now. Because I'm going to end up using both of them. There's technically two transversals here. Notice I have this and this. Come on, do the thing. It's not going to do the thing. I'm just kind of highlighting to show me, and then I'm kind of turning it to the side a little bit so that I can more easily see it. I don't know why, but I like my parallel lines on the top and the bottom. It doesn't matter which way they're situated at all. But you guys can't see that I'm turning it to the side, so I guess it really, really doesn't matter. Let's go back a little bit. Nah, we don't need to go back. I can use a couple of corresponding angles. I mean, or alternate interior angles or exterior. So notice this right here. This right here is an alternate interior angle. I got the word right the first time and then second guessed myself. So this should be 94 degrees. So that's just what I noticed. Maybe it's like this angle that I'm going to call X. X is congruent to 94 because alternate interior. Because alt interior. Okay? So X is congruent to that. I've just called it X. You can use whatever you want. It doesn't matter. I just like doing that to keep myself organized. But notice both of these, you know, like if this is the line right there and if that's the line, they're both on the interior of the parallel lines and they alternate the side of the transversal and the which parallel line they're dealing with. So that's 94. What's cool about that is that that means that I can also find this because these two form a linear pair. So let's just call it Y, just to have something to write down. You don't have to do that. Y plus 94, because that's X, is equal to 180 because it's a linear pair. So you could always do, say, let Y be this angle on this. Normally, these would be labeled better with vertices and points and labeling the lines and all that kind of stuff. But the book doesn't really do that, and I don't know why. But if you take 94 away from both sides, you get Y is equal to, what is that, 86? 86. And then that's going to let us have two of our three angles. Which means that we can find, we used alternate interior, linear pair. You know, maybe I do like one of these, boop. And then maybe I do like one of these, boop. Add to 180. And then for sum of angles in a triangle, interior angles in triangle, I'm trying to go fast with that, equal 180. So I can take that 86 plus 57 And that's going to be equal. Oh, and this one I'm going to call Z. Z plus all that. So those three angles of that triangle should be equal to 180. So Z plus 86 plus 57. 80 plus 50 is 130, plus 13 is 143. And then I'm just going to solve. No mistakes, just happy accidents. 180 minus 43 is like 37. So this right here should be 37. And that's another linear pair with that, so I can subtract that off. But what's cool about all this is that I can actually do it a different way, and I'll show you what I mean. So Z is that, and I've just labeled these. You don't have to do that. So that's how I figured out, so sum of interior angles is equal to that. That's how I figured out that. And then for number 5, G and Z are linear pairs. And that's how I'm going to find G. So right here, we're going to get 37 plus G equals 180. So subtract 37 to get G is equal to 143. Interesting. So I've just confirmed that that is correct, but what if I told you there was an easier way? We could have stopped right here with all the transversal stuff. We didn't need the transversals for a while. We could have stopped right here without even finding this Z that we invented and remembered, because it just dawned on me. You don't always have to remember everything all the time. You just have to understand it when you do remember. This is an exterior angle to that triangle, which means that it is going to be the sum of the opposite interior, or the remote interior. So it's just going to be 86 plus 57, which is equal to 143. We could have gotten our answer right there. We could have gotten our answer a lot of ways. We could have done a linear pair right here to figure out what this was, and then we could have done the same thing for that angle. There's so many things that we could have done. But, like if you want to go through it a different way, go ahead. There's just lots of ways to do it. I'll put a little or right in here. We kind of go back a little bit. Kind of make a thought bubble. Or exterior angles are, exterior angle is equal to sum of opposite interior angles. We don't want to write a lot. There's a lot of ways to go through this, but this is the one that me and Mrs. Zenos differed on the way we did it, and it differs from the way the book did it. So there's a lot of ways to go about doing this one. So let's have a quick look about it. I kind of want to keep that to the side. So this one right here can throw a lot of people for a loop, because number one, we have to remember we're not dealing with a triangle at all on this one. We're going to have to make some triangles by drawing auxiliary lines. So auxiliary lines are those types of lines that you define in some sort of way. So me personally, I'm going to show you how I did it. I'm going to show you how Mrs. Zenos did it, because I think hers is elegant and she thinks mine's elegant. And so there's different ways to do it. I just didn't think of it. I want to point out this is not necessarily a right angle. But I made an auxiliary line. Define auxiliary line. And before I do this, I'm going to go ahead and kind of copy this, because I would like to do it the other way as well. What? Delete. Delete. Copy. Back. Put it right here. There we go. You guys all saw my failure in 4K. I'm kidding. There's no way this is 4K. It was filmed with a potato. All right, let's look at this. So straighten out. So on this one, I like drawing an auxiliary line right here. That's what my brain did first. Define aux line to separate it into two triangles. The reason I'm doing this is that I know two of the three angles of this triangle, and this is perfectly fine to define. You can't just draw a line anywhere. You have to define it some way. So this is just an extension of this line right here. That's why I'm able to do that. It has some sort of definition where we extend this line segment further. And then I'm like, okay, well, I'm going to call this angle X. So angle X can be found using the fact that the sum of angles in triangle equal 180. So then I can kind of do that, and I can kind of say, all right, well, 72 plus 25 plus x equals 180. Do the same thing that we always do, and then I get 99 plus x equals 180. Subtract off that 99 to get x equals, what is that, 81? And then I can realize that this is 99. Maybe I get this by the fact that it's equal to the sum of the opposite interior angles. Maybe I didn't even have to do this step right here. There's so many things you can do with this, so don't freak out if you're not quite sure about what method you want to use. Either way, so I'm just going to point to that. So either way, I have two angles in this triangle now, and I have 99 plus 30. So I'm going to call this Y, angle Y. Same reason as above. Just for y'all. Y'all know what just happened. Y'all were watching the video, I hope, not skimming. So this is going to be 99 plus 30 plus Y equals 180. 129 plus y equals 180. Subtract 129. Y equals, this is like, what is that? This is 71, I believe. 71. Unless we goof something. There's always that possibility. All right, so we had the 72 and the 25 to get 99, and then we're going to get 81 right here, and then 99 right here, and then adding these two together, we get 129, which is not 71. Why didn't you guys stop me? It's 51? 51? $129. I feel like this is wrong. I feel like I made a calculation error, and that's a common thing. And so that will give us I hope you guys can tell me what I goofed up. There's a calculation error in here. This is 83, I believe. This is 97. 97 is what you get when you add 72 and 25. You get 97. I don't know why you guys didn't stop me. Oof, oof. Now, if that happens to you, I forgive you. It's the logic that I care about. So then I'm going to subtract off this right here. I'm going to get 97 right here to get 127. And then I'm going to subtract off the 127. And that right there is how I'm going to get 53. So much better. So much better. And then anyway, so we get y is equal to 53, and then linear pair with that. Linear pair y and h. And we're going to say 53 plus h equals 180. So h is equal to 127. And so we get the measure for this angle is 127. Now, here's the thing. I goofed up on that one, but I wanted to show you my issues because that's a recreation of exactly what happened when I did it. And I wanted it to be realistic so you guys understood it. But at this point right here, I could have gone way faster. I could have, the second that I did this right here, once I got that right there, there could have been a more elegant way to do it. But those are the kind of mistakes that I made when I first did it. Now, when you're doing it, you're going to want to pay close attention. You want to make absolutely sure that you have done your calculations correctly. You want to make sure that you didn't accidentally make any tiny goofs. Okay? So like right here is where I made the mistake. So this should have been 97. And then this should have been 83. 83. Yeah, 83. I'm double checking. But even me, as a person who's done all of my college math, all of my math for physics, all of my math for math's sake, all of my graduate level math courses and stuff like that, even I'm prone to arithmetic mistakes. That doesn't mean you're bad at math. It's about following the logic of it, because that's true math. So anyway, so you can do that, and you can go through this whole process. Now, there's a couple of other ways to do it as well. This was the longer way because I didn't realize a couple of easier things that I could have done. I could have used an alternate exterior, the remote interior angles right here, instead of having to even find this. I didn't even need to find this at all. I could have just, if I remembered the remote interior thing at the time, I could have just said, okay, well, this angle is that. And then I could have used this right here and realized that this is an exterior angle and just use these. So that's another method to do it. Now, the way that would have looked had I done it that way, because this one's an oofy problem a little bit, it would have been like, okay, well, this angle right here is equal to 97 because opposite interior or remote interior, which means if that's true, that this angle right here is also an exterior angle to this triangle. So it's going to be the sum of both of these. So it's going to be 127. Do you see how much faster that works? Now, that's still my solution. It's just that you don't have to do it perfect every time. Nobody's asking if you're doing it the most efficient way, just as long as you understand each part of it. So I'll put a little faster using remote interior to find exterior. So if I call that one x, I can say x equals 72 plus 25. And then h equals x plus 30, which was equal to 97 plus 30. Okay, well, what if we did it Mrs. Zenos' way? Which is also really elegant. By the way, when she saw it, she saw the finished product of where I did it the fast way. So don't tell her I struggled the first time for a second. So she put her aux line right here, which is really cool. And she didn't write this, but she did. She said, this is x and this is y. And then she said, okay, well, if we put our aux line right there, we can find h. We don't actually care what x and y are, right? We care about the fact that we find h. And h plus x plus y equals 180. So she went through that and she wrote that down. And then she said, this one will be pretty easy because it's going to be the whole angle of this whole triangle, right? So she said that x right here, that she made a second equation. She said, okay, well, 72, which is this angle, plus 30 plus x, that's that whole angle. This right here is this whole angle right here. It's 30 plus whatever x is. We don't actually care what x is. That's the benefit of having x. Plus 25 plus y, because we don't care what y is. We just care about what this whole angle is. And that's equal to 180. So she said 72, 102 plus x plus y. 127 plus x plus y equals 180, right? And since we don't care what this is, that's h, because that's in our first equation. Look at our first, compare real fast our first equation to our second equation. Compare those. H plus x plus y equals 180. But this is the same exact equation. It's just saying, instead of h, we have 127. That means h has to be equal to 127. Look, that's the same answer. Man, it looked like it was kind of roundabout. And me, I like having precise definitions for what those angles are, each individual part. She was able to abstract it to where she realized, I don't care what x and y are. I'm just going to use them to find h, and I've got this thing that says exactly what h is from this. So, it just depends on how your brain works. It just depends on how your brain works. There's so many different ways you can do it. So let's move on to this one. This one might not look like there's a transversal, but guess what? There is. If I extend this line over here, and if I extend this line over here, the transversal is way more obvious, isn't it? Transversal is way more obvious. So that means that we can use a bunch of different facts. We can use, we've made a triangle right here, which is going to help us. And I can use the fact that I have corresponding angles right here, or I can use the fact that I can find this. It doesn't really matter. Whatever you want. This is alternate interior angles. One, extend lines to see the transversal. Now that's not part of a proof, really, but I like saying it either way. Two, these are alt interior angles. So let's just call this x. X is equal to 125 because of this right there. And then I can find this whole thing right here with a linear pair. (125) plus y equals 180. Subtract 125. And then we get y is equal to 45. 55. 55. And then right here I have a linear pair. Linear pair. 115 plus, I'll just call it z because why not, equals 180. Subtract 115. Z is equal to 65. And now I have two angles in this, so I can say 55 plus 65 plus I equals 180 to get 120 plus I equals 180. Subtract 120 to get I equals 60, and we're there. We're there, 60. And I have already confirmed that as well. Did you not do it like that? That's okay. That's fine. So if you didn't didn't quite do it that way, we could have instead, as I told you, there's so many different ways to do it. We could have instead drawn those lines and then realized this right here was a linear pair, figured out that this was 65, and then we could have said, all right, well, 115 is equal to 55 plus I, because they're remote interior, and then you could have set an equation up like the last one. There's a lot of ways to do it. You could have used corresponding angles right here to just have to straight up do the linear pair for that one. So many ways. This one's pretty easy, except for it's got variables, and that throws y'all off a lot. So one thing that you can do is you can say, all right, well, this right here is a linear pair. Or you can use these two angles and the fact that they're remote interior with that one. So whatever you do, you know that this is a remote interior angle, so 10x minus 20, this angle should be equal to both of those opposite interior angles, because it's because of this line right here. It's because of that line. You guys all see that there's a line right there? That showed up here too. We had a triangle with a line that's extending the base. That shows up in a lot of places. Where's another good one? It shows up right here. A line and then a triangle. It's one of the sides of the triangle is part of a line. That's what happens. So we know that if I add these two together, it should be equal to this. So we're going to use that. 5x minus 3 plus 4x minus 2, because this plus this is that, which gives us that. So 10x, let's combine some like terms before we start really fiddling around with this. 5x plus 4x is 9x. Negative 3 plus negative 2 is negative 5. And then I'm going to subtract 9x from both sides to get x minus 20 equals negative 5. And I'm going to add 20 to both sides to get x equals 15. X is equal to 15, but the thing didn't ask us for x, did it? It didn't ask us for x at all. It asked us for this whole thing. So there's a couple ways we can do this. We have x, so now we can say j plus 10x minus 20 right here, linear pair, equals 180. And then we can say j plus 10 times 15, because we know what x is. J plus 150 minus 20 equals 180. J, just simplifying as we go, 130. Subtract 130 to get j equals 50. And according to my teacher's handbook, that's what it is. But the teacher's handbook doesn't say anything like that. Their solution is just, if parallel lines are cut by a transversal, the alternate interior angles are equal in measure. Linear pairs form a supplementary angle. They don't tell you anything about how to do it with variables. They don't tell you anything else. They just kind of give a vague hand-wavy thing. And number 11 just gives the angle. No actual explanation. But it requires y'all to have the explanation, so that's not fair. So that's why we're going to go over it. But wait, Mr. X, what if I had instead done all of these angles add up together? Well, 5x minus 3 plus 4x minus 2 plus j equals 180. And then I can simplify a little bit. 9x minus 5 plus j equals 180. And then 9 times 15 minus 5 plus j equals 180. 9 times 15 is 90 plus 45, which is 135. Minus 5 plus j equals 180. 130 plus j equals 180. Subtract it from both sides to get, again, j is equal to 50. You should get the same answer regardless of the way you do it. So let me kind of move this a little bit over to the side or a little bit up. Something like that. I know it's gross, but nobody's going to really look at it too much afterward. Okay, so this one's a little bit rough. I want you to pause the video for just a second and ask yourself, what do you notice about this? There's some symbols. There's some interesting symbols on this one. Well, I hope what you noticed was that these two sides are congruent. Notice big triangle has two sides equal. So base angles. So what I mean by base angles are you have these two sides are congruent, which means that these, the ones that connect to the angles that connect the side that's congruent with the side that's not congruent necessarily, those two are equal. So, base angles are congruent. But we have a property about isosceles triangles. This angle x and this angle that I can also call x because it's an isosceles triangle are equal. That's why I can give them the same letter. They are equivalent, x and x. Okay? So now we have, with the base angles, we can say that the sum of angles in triangle equal 180, which means we can take that 56, plus x, so plus 2x's equals 180, and we can find out what x is, that whole angle. So if I subtract 56 from both sides, I get 2x equals 180 minus 56 is like 24. So x equals 12. So whatever x is, I don't really care what x is. Nobody wants x. Nobody cares about it. But it's 12 in this case. So this entire angle is equal to 12. That should be 124, by the way. So it should be equal to 62, 1. So it should be equal to 62, actually, not 12, not 12. Watch out now. Okay, so if x is equal to 62, we can figure out exactly what, we can use that exact same thing over here. If you turn it to the side, you can realize this is also an isosceles triangle, which means that this angle is also x. So we can do k plus 2x is equal to 180. But doesn't that look exactly like this right here? So 56 is equal to k. When you have two equations and the only thing different is one value, you have 56 plus 2x equals 180, but also k plus 2x equals 180. Then k has to be equal to that thing that was different right here. Or you can do what's called a substitution. You can solve this for k and then plug it in, or you can solve this for x and then plug it in. Regardless of what happens, it doesn't really matter. So since there's a word called isomorphism, which is a word you guys don't have to remember at all. It just means that two things are the same form. They look different, but they're the same form. So that's one way to do it. That's one way to do it. There's a lot of ways to do it, though. We could have set up a system of equations to figure this one out. We could have done the actual substitution right here to plug x in to this to make it only have one variable. If I had done that, I would have had 56 plus 2x equals 180. Subtract 56 from both sides to get 2x equals 124. And then when I substitute, I get that. And then I just plug it into this equation to figure out what that is. So if I did that, I'd get k plus 2 times 62 equals 180. So I get k plus 124 equals 180. Subtract 124 to get k equals 56 again. Another thing I could have done is I could have realized, I could have used, I think that might have been one of the simplest ways to do this one. I feel like a system is really easy. There's a lot of things that are really easy. I could have done 180 minus x and just left it as x. And then I could have called this one x minus k right there. And that did 56 plus 180 minus x plus this angle right here is going to be x minus k. And then I could have done that and a bunch of stuff would cancel. And I'd realize that, hey, it's just this angle. What? It was just that angle? It was staring us in the face the whole time? That's ridiculous. And by that, I mean, we could have said this angle right here is a linear pair with x. So this angle right here is going to be 180 minus x. So it's this whole 180 degree minus this. So 56 plus 180 minus x. And then right here, to find this angle, I could have called that x minus k, so plus x minus k. What? That's a 6. And in that case, I'm adding this angle, which I've defined abstractly using x and 180, and then this angle, and then this angle, and when I add them together, it should be equal to 180. So the second I subtract that 180, I suddenly have 56 minus x plus x is 0, so this cancels with that. Honestly, this cancels with that, so I just get 0 on the right side, and I get 56 minus k equals 0. Add k to both sides, and I did this to show you some stuff. Notice I get the same thing. So you're free. You have so much freedom in so much of this, so don't second guess yourself too much, okay? And for the record, for something like this, 95 plus something, this whole angle right here is equal to 180. So this whole angle has to be equal to 85. Knowing that whole angle is pretty nice. Because then I can set up a couple of relationships, like I can call this x and then say 85 minus x is what this angle is, or I can say x, I could say that x right here, I can use, I could use remote interior. There's a lot of different things. I'm not going to go through the entire problem set, though. I just kind of wanted to kind of look at some of these and say, you know, some of the logic you can think of. I didn't really need that. I can figure out this angle. I can figure out this angle because this angle right here is 95 plus 39. Because, remember, I can call it x and say this is equal to 180. 95 plus 39 is 120 plus 14, so it's 134. So I can subtract that from both sides to get x equals, what is that? It's not 56, so 46. And then I can use that with the fact that I have transversals here. Or, you know, maybe you start off a different way too. Maybe you realize that you have alternate interior angles right here, and so that must be 39. And then to figure, this is the, let's see, if I have that as 39, so I can get 95 plus 39, call this y plus y equals 180. And then I can figure out what y is, so I get another one of those cases where I get 134 plus y equals 180. So y has to be equal to, subtract that, and I get 46 as well, which is kind of cool. But it's also the fact that it's a corresponding angle with that other one, but that one's a lot harder to see, I promise you. Because this right here can be thought of as the transversal between this parallel line and that parallel line, even though it doesn't look like it. Regardless of what you do, you get 90 plus 46 plus a equals 180 because of all of the angles in this triangle. So you get 90 plus 46 is 136. Subtract that off and you get, what is that, 44? But again, that was less to show you how to do each one of those individual ones, and it was more to show you how many ways you could do it. That's what I really want you to take away from this, is that's the necessity for explaining it. That's the necessity for proving it. And that's the skill you're going to have that's outside of math that that you'll use for the rest of your life, is being able to explain what you do, even if you do everything really complicated.